Now let's solve this problem that we have just calculated it using the dynamic programming approach. We came up with this algorithm that we have to iterate through each of the coins and then use this formula and try to find the minimum out of it. So I'm in my IntelliJ in presentation mode. So let's solve this problem here. And I will take this method name same as here. And I will mark it as final. Argument should be always immutable. Now let's see here, right? So we created this DP array of amount of length 11 plus 1, which is the amount of 11 plus 1. So we do the same here. Amount plus 1. And let's fill it with a minimum value of something which is greater than 11. So because we also have to check condition that suppose there is also a possibility given here that in this scenario, when we don't find any combination and when we have to return -1. So for that base condition, let me fill. Otherwise, I mean, we know that in Java by default it would be put as 0. We don't want that. We would want some value which is greater than amount. So either we can choose amount plus 1, or we can choose any number which is greater than amount, which is our false condition that we haven't found any combination. So amount plus 1 can be amount plus 1, amount plus 2, amount plus 3, whatever. Or we can also choose Integer.MAX value, right? So we can choose anything which is greater than, which is our false condition that we haven't found any coins combination which is possible to make this amount. So I'll go with the simpler version. I will take amount plus 1. So we found that for our DP0, our base condition, it's always 0. So I will put DP of 0 as 0. This is our base condition. And now we will iterate from I is equal to 1 to 11, right? Amount. So here we have seen that in this algorithm, we iterate through each of the coins. So I will iterate through each of the coins. I will use for each final int coin, right? And from the coins array given. Okay, and first of all, we need to see what is the change. It would be the amount, the given amount minus coin. So here we're talking about this part, amount minus coin. Amount for a particular index is I. So amount minus coin, we have to iterate for each of the coins and use this as a change, because this is the change or the amount left after I remove this coin from the amount. This is what we are denoting here. And we can only check that if, for example, if the coin is, say, for example, 5, we can't use it for 3 or 4, right? So it means that we have to check that condition as well. That only if the change is greater than equal to 0, only then we have to consider that coin. And then this formula is very simple now, that we have to use dp of I, and then we have to choose the minimum that we have found before, dpi. So you know that dpi we have put default as amount plus 1, right? So it would be only the base condition that if we don't find any combination, then it would be 11 plus 1, that is 12. Or otherwise, if we have one condition, then it would be dp of this change. One plus dp of change, right? 1 plus dp of change. We are iterating through each of them and finding the minimum. This is what we are doing here. If it doesn't find any combination, then it will default, we put as amount plus 1 as 12, which is our false condition. So that's it about, guys. We have got this for loop and we have implemented this algorithm already. And then finally, we need to return. There are two possible conditions: that we don't find any combination. For that, we have to return -1. And if we have found any, then we have to just return the dp of that amount. dp of amount, that is dp of 11. So here I will just write a short, if the dp of amount is not equal to amount plus 1, I mean, we are just checking that this condition there is true or not. And if it is not equal to amount plus 1, so it means that we have already found the solution. So we just return dp of amount. Otherwise, we return -1. If it's still equal to amount plus 1, 12. So if we have got this 11 as put as 12, then it means that we didn't find any combination. That's why we're returning -1. So that's all about this algorithm in just few lines. This is the beauty of dynamic programming. So let's run this problem with the statement given here. I'll take coin change and new int, and then pass, I think it was 1, 2, and 5. And the amount given is 11. So I've taken all the examples given here in lead code. First example, 2 and 3 and 1 and 0, and we expect the solution should be correct. So let me run this. It's 3, -1, and 0. It's matching with this 3, -1, and 0. Now let's copy this solution and then put in lead code and submit it. Yeah, so it works well. So our solution is working fine for all the scenarios possible. Let's quickly do the time and space complexity analysis. So that for the time complexity, we see that we are having 2 for loops. So it would be amount multiplied by the size of these coins, because this is the second inner for loop. So amount multiplied by coins length. Or in other words, we can simply write it as O of n square. And for the space complexity, we are only creating one dp array. So it would be O of n. So guys, that's it about coin change. In our next, which is the 10th problem in this tutorial series, we will solve yet another very interesting problem of house robber. It is not very as complicated, but it's very good to understand the basic dynamic programming approach. So this is our 10th problem in our tutorial series, which we'll solve in the next video. So see you all in the next video.